Our engineering management platform, Jama Connect, enables an intelligent, guided, and measurable product development approach. In Jama Connect, we use process rules to define end-to-end engineering and design processes. Jama Connect will leverage this process to automatically guide the engineering organization through their development, intelligently measure system and process completion, and automatically detect gaps and risks so that engineers know where to take action. On a high level, our nuclear reactor design framework starts from the decomposition of the requirements and the parallel decomposition of our designs and architectures from the highest level of the plant all the way till the mechanical and software implementations. The framework natively enables the initial deterministic safety assessment, the classification of initiating events and design-based accidents, the categorization of security and safety functions, and the classifications of structures, systems, and components in alignment with the guidance of the IAEA and local nuclear reactor design assessors. The framework also includes the probabilistic safety assessment, the accident and dose consequence analysis, and the analysis of combined risks. Nuclear reactor design is highly iterative. As our design and construction progresses, we will continuously find new safety and security requirements and functions, as well as new reliability requirements and special treatments, all of which will need to cascade and feed back into the functional and non-functional levels of our reactor. Nuclear reactor design practitioners integrate model-based systems engineering, product lifecycle management, pipeline and instrumentation diagramming, and software development tools to Jama Connect to extend the traceability from the definition of our reactor to how our reactor is being implemented in mechanical, software, and electronics disciplines. These integrations will enable us to programmatically measure traceability and system completion across all of our tools, part of the engineering digital thread. For example, from one of our high-level mission needs, energy efficiency, we can directly visualize the allocation to a plant design coming from a model-based systems engineering solution. And then we can follow the decomposition of the requirement and the plant design all the way down to the mechanical implementation. For example, from this plant design, we have derived multiple system architectures of the key reactor systems, which are further decomposed into multiple subsystem designs, which are further decomposed into component designs, which are ultimately decomposed into mechanical implementations like parts and key assemblies. This end-to-end traceability across the entire digital thread will enable us to understand the impact of changes starting from a requirement all the way down till the lowest implementation level. For example, if I were to change this energy efficiency requirement, I could run an impact analysis in Jama, and then Jama would show me that multiple design levels would be impacted by the change, but 5 levels down, I would also be impacting implementations in mechanical parts. I would be impacting safety mitigations and risk mitigations, as well as executed tests, which is very powerful to understand before the change. Jama will use intelligent engineering management features like the Live Trace Explorer to intelligently measure the completion of our traceability across the entire digital thread. These intelligent measurements will programmatically summarize the completion of the decomposition of the requirements, the decomposition of the designs, the test coverage, the risk mitigations, as well as the completion of the implementation of our system. Due to the integrations with other tools like product lifecycle management or model-based systems engineering applications, we can start measuring to what extent our component designs have been implemented in parts, or our software requirements in software implementations. For example, here we can see that only 2% of our component designs have been implemented in parts, or only 2% of our component designs have been analyzed and taken into account in the initial deterministic safety assessment. These intelligent measurements will enable companies to mitigate rework and reduce their time to market. We will always be able to understand where we have gaps and risks in our system so that we know where to take action. In Jama Connect, we use the project tree to visualize and access all of our engineering data in one view. The project tree will also enable us to set up our product breakdown and systems engineering structure. Here we can see the key subsystem of the reactor and the balance of plant, each subsystem having their respective requirements, designs, and tests. And then one level down, we can visualize the key components of our subsystem. Each component including requirements, designs, tests, and mechanical, software, or electronic specific implementations like parts or software user stories. Our out-of-the-box nuclear reactor design framework also contains data models for the automatic calculations and classifications of initiating events and design-based accidents, for the categorization of safety and security functions, and for the classifications of structures, systems, and components. The Jama Connect nuclear reactor design framework will also enable the automatic export of initial, preliminary, and final design safety reports, and will enable the programmatic creation of security and safety cases. Our INC system development framework is reduced towards the scope of the development of nuclear reactor subsystems. And in accordance with standards like EEC 61513 or EEC 61508, the INC development decomposition starts at the level of the safety design base. The INC systems development framework also enables co-development. Nuclear reactor OEMs, INC system tier 1s, and external engineering partners can use Jama as a central source of truth for the entire design and engineering related collaboration. And they can use Jama's intelligent engineering management capabilities to measure system completion and identify gaps across the entire engineering data coming from all the partners from our development ecosystem. We see the adoption of artificial intelligence as essential for reducing time to market and increasing efficiency in nuclear development. Jama's engineering AI enables engineers to highly automate day-to-day and manual tasks, like the definitions of tests or the decomposition of requirements. For example, here I have a requirement related to the nuclear fuel. And instead of me deriving the test manually, I will use Jama's engineering AI to derive multiple tests automatically. And then Jama's AI will proceed to derive multiple tests that our engineers could choose to take over and relate in traceability with the requirement. This way, both the test generation and the traceability creation will be highly automated. Thank you very much for your time. If you want to learn more about our nuclear reactor design and IC system development framework, please visit our website. Thank you.